All right, welcome everybody to a new day of Computer Science 41. So SDF 1 was due today, and I want to talk about it. The reason being, just have a monkey over here. No, I can't. I can't do this. I can't do this. I'm sorry. I'm just staring at the monkey the whole time. Hang on one second. There we go. So the big thing that I saw a lot of people had trouble with was how to break down the problem, and this is a constant struggle to sort of get right. And early on in your computer science career, you start off with the professor doing something like this, like, okay, make a for loop here, and like, make an if statement, and you like kind of fill in the blanks. But this class, it's starting to get, a little more freeform, right? And so you have to figure out in your head how to break a problem down. That's actually maybe the most fundamental skill there is in computer science. Given something you need to do, you need to split it into pieces and then solve those individual pieces. And you need to make the pieces small enough you can like do them in like maybe one go, maybe 3 or 4 lines of code, and test it and make sure it's working, and then move on to the next piece. And if you get stuck, like I don't know why this code here is seg faulting or something, then you can post that one line of code like, hey, I'm doing it this way. And then somebody's like, oh, you got your rows and your columns backwards, which a lot of students did on this homework assignment. And I did so deliberately. I had the columns come first, then the rows, but in the vector, rows come first, and then the columns. And I did that deliberately to see if you guys could figure it out. Um, and you need to be able to like split a thing up, right? And so in general, there's usually three phases to the homework assignments, at least in this class. What happened there? There is usually the input phase, there's the compute phase, and there is the output phase. So which phase should you do first? Like when you're writing code, which one of the phases should you probably write first? Spam, like the email or like the food? I figure I'll get a lot of spam musubi when I go to Hawaii in a couple months. The food, yeah, fair enough. Input, yeah. So input's usually where you should start, right? So if you need to make a world that is 10 columns wide and 20 columns tall, um, start with that. And then what should come second? Spam musubi is the best. Yes, I like it a lot. Pokeball has pretty good spam musubi, I think. Output, yeah, exactly. So even though in your code it's going to be the input phase, the compute phase, the output phase, usually I do this part second. And the reason for that is because you want to be able to see the stuff that you input, right? So I usually start off by inputting something and then immediately printing it and just making sure that, okay, I've read in 5 asteroids, I print all 5 of them, and I make sure that everything's working. You need to be able to output things in order to test your code. And then I work and then I break down the compute phase into different sections if I have to. Like I might start with it doing like no asteroids. Asteroids. So I might start with like no asteroids, okay. Then like one asteroid, then like multiple. And then after that, I would probably, why is that formatted so weirdly? No. Weird. Huh. It's really strange. And then after that, and maybe as I'm going along, I have to worry about like edge cases. Like what if the asteroid off the edge? And maybe that's part of the input phase too. But like, there's different edge cases that you have to handle. And so, villainous tutor who likes sumo. And I was talking about Bill Kearney switching rows and columns. I'm just trying to see if it's good exercise for your head, because people do confuse rows and columns all the time in real life. Trust me on this. I've done it myself many times. And so the input comes in column and row format. The map is held in row then column format. You just need to develop the mental flexibility to work with that. So And the reason why I did columns and rows is because it's X then Y, right? Which is the normal way that we input things in Cartesian grids. In computer science, though, oftentimes we do row then column just because it matches our code better. So you need to like learn to split these things down. So what we're going to be doing for SDF2, and we're actually going to be, I had another lecture planned today, and I'm not going to do it because of the amount of questions that I got on SDF1. Every time I teach this class, I custom tailor it to the students. And we have 104 students in CSI 41 right now. It's actually the biggest class I've ever had. And we have a lot of people from like different people from 40, right? We got Fresno State people, we got FCC people, we got people from Lund, we got people from me. And so everybody's got different backgrounds. And so I actually, before I move on Friday to talk about classes and things like that, what I wanted to do is really hammer this point home on like how you chisel away at a problem, right? You don't just like split, and like if you're doing a sculpture, you don't just like bam and like try and knock out the sculpture in one go. You like kind of work on a piece at a time, right? Kind of assemble it into a giant, beautiful, dude or something. I don't know. And so what we're going to do today is we're going to actually do the first part of SDF2. And SDF2 is going to be rectangles and circles. What I want you to work on today is how can we do SDF1 but with rectangles in the world instead of asteroids, which is another word for a point. Right? So an SDF, and the S in the SDF we didn't use in the previous assignment. And the reason for that is because points are a point. There's nothing inside of a point. There's no negative. But a signed distance field actually has a negative component to it too. Let's see if I can find an example of this. Yeah, like that. Like this could easily be done using a signed distance field. And so when you have the interior part of a rectangle, the interior part has a negative distance. Okay. The outside of a rectangle, the number is how far away is the edge. Same as for a point. For inside of a rectangle, it's also how far away is the edge, but it's negative. And that allows you to do things like this, where you can have like a little beveled look to it. So you can, if I really zoom in on this, you can see that there's like shadows right on the edge. And then as you go inside, it sort of blends into the actual color of the font. When we come down here, when we have a vertical edge, you can see that they added a shine to it. A lot of times font stuff is actually done using SDFs. Half-Life, Valve, Counter-Strike, like their font system uses SDFs. And so they can actually expand the thickness of fonts dynamically. So for example, instead of just coloring everything at 0 distance, you can color everything at 1 distance. And then your font gets bigger. And you can use that for anti-aliasing and things like that too. And so like here, when you have a negative distance, you can actually shadow it if you're on the right side, and you can make it glow if it's on the top left and things like that. So not a Bezier curve. It's just you have a line or something, but you radiate out a signed distance field from it. And then you can adjust the threshold on which you draw the line itself. And for something like this, you can do special effects on the inside of it. So what we're going to have is insert a shape. It's a rectangle. Okay. And so what you're going to be doing today is I want you to figure out how to do this. So every point outside of the rectangle that's like 1 unit away is going to... let me pause this for a second. Let me grab my tablet. There we go. Did I downgrade to Windows 7? No. Okay. So if we have a rectangle, right? That's a terrible rectangle. Let's try with a shape, actually, and that'll be easier. We have a rectangle. And we want to do a signed distance field. Every point outside of that rectangle will have a distance of 1. That's 1 square away, right? You can imagine this on like a grid, right? And so everything that's 1 square away is a 1. Everything 2 squares away is a 2. This area up here is going to be tricky for you to figure out, but I'm going to leave that up to you. I'm going to leave that as an exercise for you guys during class today. And then everything inside of the rectangle will have a negative distance. Okay, so this guy here, I should really have drawn that shape in a different color. Let's do red. Wait. Shapes, rectangle. Okay. So everything inside of the grid will have a distance of -1 here, and a distance of -2 here. You guys see that? It's -1, -1. Oh, these are inside of the rectangle now, whatever. Okay. Does that make sense to you guys? So everything outside of the rectangle has a positive distance. Everything inside of the rectangle has a negative distance. That's why this is called a signed distance field. Okay. -2, -2, 1, -2. This would be -3. This would be -3, -2. 1, -2, -3. 1, -2, -3. Yeah, so I think it's going to look like this all the way across because it's only 6 thick. Okay. And then the lines are zeros. Yeah. I'm not drawing this very well, but yeah, the lines are zeros. Everything 1 square outside of a rectangle is 1. Everything inside 1 square is -1. And this is useful for a lot of things. Like, for example, if you were rendering fonts, like we just showed you right there, if you were looking at this spot right here, you could actually get a gradient towards where the nearest edge was. And you can see that the gradient is this way, and this way. And so you might draw like a bevel thing there. And for this guy, the gradient is pointing this way to the right because it goes from -2 to -1 like this. And so you might draw like a bevel that way. And so you can end up having like this internal beveled edge on the inside of your font, like I just showed you in Microsoft Word. I normally don't use Microsoft Word in lectures. But you can see, right? Like you can see these beveled edges here on the inside of the font. And you can implement that. I don't know if they did it using an SDF, but it's very common to do font stuff like that using SDFs. And so by looking at the sort of the differential, between, -2, -1, -1, and this one's a -1, 2, then you can like draw these beveled edges on the inside of a font. And you can thicken fonts dynamically and things like that using an SDF. It's really cool. You can also do things like if we have a circle. So let's say you have a circle. And you put this onto your grid. Every square on the inside that's 1 away is a -1, -1, -1, -1, -1. Why do I keep drawing positives? -1, -1. Things that are inside a little bit more. -2, -2, -2. Right? Why do I keep drawing positive? All right. 1, 1. And then inside more, you have -3s, right? Does that make sense to you guys? And then outside, you'd have +1s, +2, and +3, and things like that. +1, +2, +3. Are you guys with me on this? And so what you could do if you have, let's say, a pillar in water, then so we'll need 4 inputs with a specific shape. Yeah, there's point, rectangle, and circle for SDF2. And so you'll be able to add a point, and then the point will work just like what you have already. It's literally your existing code, so don't throw it away. Everything that's 1 away is +1, and then everything 2 away is +2, and so on and so forth. You're going to have a rectangle that can have negative distances on the inside and positive distances on the outside, and a circle that can have negative distances on the inside, and maybe there's a -4 in here somewhere. And positive distances on the outside. Okay, that's going to be maybe your next homework assignment. Depending on how this goes, I might give you a softball in the interim, actually, between it. So how do you do that, right? Like, for a circle, it's actually pretty easy. I hate saying that because students hate it when I say that, right? But for a circle, what describes a circle, actually? Let me toss this out to the audience. How many variables do you need in order to represent a circle on a Cartesian plane, let's say? Pi? Do you need pi? I don't think you need to write it down because all circles have pi inside of them. Apple pie, cherry pie, raspberry pi. X squared plus y squared equals r squared. Yeah, so you need 3 variables. However you want to put it, you're going to need 3 variables. You're going to need an x and a y, and that's a point or an asteroid, if you want to call it, for the center. Yikes, what just happened there? I'm not even touching the tablet. It's so weird. It just suddenly just started spazzing out. All right. So this is the center of the thing. You also need a radius, right? So you need 3 numbers to represent a circle. You need a position and you need a radius. And then if you want to do a signed distance field for a circle, it's actually not hard. I hate saying that, but again, all you have to do is like, if you're like at this grid point here and the center is here, you do the Pythagorean distance. You're like, oh, it's 2 away. The radius is 3. Okay, I'm at -1. Right? If the radius is 3 and I'm 2 away from the center, -1's the answer. It's that easy. It really is. So we're not doing circles today. It's too easy for you. So math tutor over here. Find a center point. Figure the radius is yep. You got it. And the difference of our distance and the radius is the signed distance field. That's it. And if you're bigger than the radius, well, it's still the difference. You know, like if we're this point over here and we're 6 away, if we're 6 away and the radius here is 3, then 6 minus 3 is 3, and we write down a 3 there. It's that easy. Circles are too easy. Rectangles, though, takes a little bit more brain power to think about. So how do we represent a rectangle? I know at least 3 different ways that we can do it. All of them are going to need 4 numbers, either a float or an integer, depending on whether you're aligning it to the grid or not. So we got 1 vote for corners. Okay, that's certainly one way you can do it. So one way you can represent a rect, if you want to get rect. One way you can do it is the corners. And so you're going to need like an x1, y1 kind of thing for the bottom left, and like a x2, y2 for like the top right. So you can have like these two, right? You can have like x1, y1 down here. Like you have a point for the bottom left corner, you have a point for the upper right corner. Does that make sense? I've written rectangles many times this way, where you have a min x, min y, max x, max y. You're done. Okay. Could you use the area of a rectangle? No, because you don't know what shape it is. Like you'd have a 25 by 1, or you'd have a 5 by 5. You can't use the area in a rectangle to hold it. Another way we can do it is what Dermer said, which is you have like, let's say min x, min y, and then you can have the width, it's a w, believe it or not, and the height, which is an h. And so you can have x1, y1, the min bottom left corner, followed by the width, followed by the height. So that is certainly a option. I have done it that way as well many times. What is another way we can do it? Yeah, Voss was in the previous class, so he knows the answer. So you can have a center point here, and so that would be x1, y1, but not this time. It's not the min. This time it is the center, kind of like the center of a circle. And then kind of like the radius, we can have what's called the half size written down. So we can have the half height and the half width, if that makes sense. And so we would have an x1, y1, and then half width and half height. And we actually are probably going to do this for the signed distance function. In fact, we are going to do this for the signed distance function. You need to have the center point and the half width and the half height. And the reason for that is because when you do it that way, getting the distance to, like if you're talking about this person out here, let's say they're 1, 2, 3, 4, 5, 6, what's it, 2, 7 away, and our half width is 4, let's say. 7 minus 4 is 3, and that's a 3. Okay. So yeah, corners are oftentimes how I will do it, because that makes your for loops really easy. Starting at minimum x, going to maximum x. Starting at minimum y, going to maximum y. You know, do something. With a signed distance function, though, you want to probably do it this way, because it makes the math really easy. If you are 7 units to the right of the rectangle, then you're 3 away. And it's actually true up here as well. If this location here is x1 plus 7, if it's 7 to the right of the center and the half width is 4, then you get a 3, right? And if you're north of the rectangle, then you just subtract out the half height. So if you are 5 squares up, if you're 5 squares up here, and the half height is 3, well, 5 minus 3 is 2. That makes sense? So I would like it's the corners though. It's this area up here that you have to think about. I'm not going to do that for you, okay? And I'm also not going to tell you exactly how to figure out when you're inside of the rectangle. I want you to think about that too. It's not hard. I keep saying that. You can probably figure it out. And you're going to work in groups today, okay? So what I want you to do is put your heads together. I'm going to assign you into groups right now, and you're going to go into breakout sections, and you are going to work together on trying to put together. There's no homework for this yet, so just make it in some blank file in your directory or whatever, and you can all share the code. It's all good. I recommend that you all go into like a private group chat or something, and one person streams and everybody talks. And you're probably going to need to do the following things. You're probably going to need to make a rectangle class. You're probably going to need a like distance to function. Where you like figure out the distance to the rectangle. You pass in a point, you get a distance. So it takes in a point, and it gives you a distance from the rectangle to that point. What else? What else do you guys think you'll need to do? Like I said, today's topic is how do you break down a problem? What other things are you going to need to do for SDF2? We talked about this already. What's the first thing you should be doing for this? What's the format for the input? Great question. The format for the input is going to be this. Let me write it down. Yeah, so you want to work on the input. So I would even split up this task among the different people in the group. So maybe have one person design a rectangle class, one person design the distance to function, and then one person do the computation of the grid, right? Where you actually, for every point on the grid, get the distance to the rectangle and print the result. Okay. And so the input is going to be same as SDF1, almost. It's going to get a grid width, a grid height, but then you're going to take in a X and Y for the center. And you're going to take in a half width. And you're going to take in a half height. And you're going to take those in a loop. So you can get multiple rectangles on the screen. And there's a really interesting question of what do you do if the rectangles intersect? Which number do you draw? And in the previous class, we agreed if there's an intersection, like if two rectangles are like on the, they're overlapping somewhat. If intersection, pick the number closest to 0. So if one point is like 9,000 away from a rectangle and another one's 3 away, whether it's positive or negative, it doesn't matter. You pick the 3. So whichever one is closest to the nearest line, that's the one you use. Okay, so it's not the smallest number because negative 9,000 is smaller, right, than negative 3. You pick the one closest to 0. And so this is what you guys are going to be working on for the rest of class today. You're going to share the code with each other, and this will give you a good kickstart for SDF2, which is almost done. So, all right. So let's, what is the format for the input? So you understand? X, Y, half width, half height. In a loop. You're going to read that in a loop until the user types in -1. It's very close to the same as SDF1, except you got 2 more numbers there, which is the half width and the half height. Okay. Always integers? No. This one is going to be all floats now. So it is all flutes. Good question. So you can have a half height of 3.5, and that's a rectangle that's 7 tall, right? Kind of has to be floats. Doesn't have to be, but kind of has to be. Yeah, if we only had even-sized rectangles, sure, but yeah, it kind of has to be floats. Can we get a README file? No. This is your README file. I want you to try and work together with just this on the screen, and put together a good solution, as good as you can. Okay, it's a listen me file. That's exactly right. Okay, so let's let's get you guys partnered up. All right. So when I say your name, like sound off, like on chat. If you don't say anything on chat, I'm gonna skip you and pick someone else. Okay, and then you don't get a group. All right, Alessandra, are you here? Ann Lizing, are you here? Aiden Messick, are you here? Aisha, are you here? Okay, the 4 of you guys are a group. You can disconnect from voice chat in a second, and I would recommend you guys just go into a group chat with each other, and then one person stream their code and start looking at it. Next up, we got Salah and Salah. There's 2 of you guys there, right? You're a 2-headed giant, right? Okay, so there's 2 people in the form of one body. If we have a chat with a few others, can we hop into that as a group? Yes. So which 4 are you talking about, Hawkman? That might speed up. Cunningham, are you here? Okay. Sorensen, are you here? All right. Actually, I can probably stop the recording at this point. I'll resume if there's any, interesting points. If not, I'll just stop the recording.